Awesome. Well, welcome everybody to our monthly webinar with the AAPG Petroleum Structural Geomechanics Division. Today we have Dr. Bruce Black with us. I actually met him a few weeks ago at our AAPG Mid-Continent section, and he came highly recommended from my co-chair, Steve Ladner. Steve saw Bruce give a talk, I think it was a year ago at the RMAG Helium conference, which was a big success. And so Steve saw Bruce, so we had to get Bruce over here with us. And Bruce was gracious enough to come to Oklahoma City for our sectional meeting and give a talk. And he also had a booth with this prospect. There was a lot of great structure involved, a lot of kind of oil and gas, helium, a really great story. So I really wanted to give Bruce a platform to tell this story for us, because I know we have a lot of people that enjoy structural geology, oil and gas, as well as helium. So with that, let me go ahead and introduce Bruce to you. Bruce is a native New Mexican born in Albuquerque in 1936. He graduated from Highland High School in 1954. He entered the University of New Mexico in 1955 and joined the Navy Reserve the same year as a seaman recruit. He transferred in 1956 to Texas Western College on an athletic scholarship and graduated in 1959 with a BS degree in geology. After graduation, he went on active duty with the U.S. Navy, going through the Navy Officers Candidate School, and was commissioned an ensign in 1959. He married his wife, Marjorie, of 64 years after graduation. He served 4 years on active duty as the intelligence officer for VP-50, a Navy seaplane squadron in I'm going to mispronounce this one, Iwakuni, Japan, and later as an intelligence instructor at the Pacific Fleet Intelligence Training Center in Alameda, California. After active duty, Bruce stayed in the Naval Reserve and returned to the University of New Mexico, where he received his master's degree in geology in 1964. He then joined Shell Oil Company, where he served as Shell's district geologist in Ventura, California. Then as assistant to the vice president of exploration in Los Angeles, and eventually as a senior staff geologist in Farmington, New Mexico. Bruce left Shell in 1970 to form his own exploration companies. He received his PhD in geology from the University of New Mexico in 1974. He has explored the Rio Grande Rift for over 52 years. In 1985, he found, produced, and sold the first oil out of the rift. His civilian and Navy careers continued to intertwine as he served on and off of active duty with the Navy for over 41 years. In 1992, he was promoted to Rear Admiral and retired from the United States Navy as the commander of the Naval Reserve Intelligence Command in 1996. Today, he is president of Black Exploration, LLC, and consults as a frontier explorationist. He is currently active in rift exploration in the Rio Grande Rift, including exploration for helium, and on the Zia Pueblo in the rift. So with that, Bruce, I'm going to hand this over to you, and looking forward to it. Thank you again.
Okay. Thank you, Molly. I hope everybody can hear me all right. And want to thank Tim also as the co-host. I'm going to go through these slides relatively rapidly, and then we can go back and look at individual slides if you want to give you the full story. It's really a search in my mind for a giant oil and gas field, which is something I've always wanted to try to find in my geologic wanderings. But the reason I want to stress this is because this is a play in the Rio Grande Rift, and rift systems, as you know, around the world, they only constitute about 2.5% of all of the producing basins, and they're only about half of them do produce. But those that have source rock and all of the parameters you're looking for, produce something like 12% of the world's oil reserves and up to 4% of all the gas reserves. So rift exploration is important, and you see a disproportionately large amount of oil and gas fields in rifts. So I thought that'd be a good place to look for oil and gas. With no further ado, let's go on. This first slide gets you oriented. Now, this is a picture. If you can see can you see my cursor all right? This is the Four Corners, and this is the state of New Mexico right in here. The reason I'm showing you this is we're going to come back to it later, but we have some important features that are going on here. The Jemez lineament is a well-known structural element that comes up from Arizona and is marked by a number of Quaternary and Pliocene volcanic emanations on the surface, and it intersects with the Rio Grande Rift at the Jemez volcanics, Jemez caldera. The rift, as you can see, comes up north-south, hits the area. The rift then takes a jog and goes, I'm sorry, this is getting off, goes off to the east a little bit, and then goes north-south again on up into Colorado. So I'll come back to this, and it's important because this intersection is a place where there is a deep crustal mantle weakness, and the Rio Grande Rift, of course, enforces that. Just since the Miocene time, it intersects that Jemez lineament, and I think this is one of the main reasons why we have helium and hydrogen coming up where we have on our lease. The lease we're going to be talking about, you can see there is labeled Zia lease. Okay. This is a close-up of the Four Corners area, and I'm showing here the San Juan Basin. In this area, there's over 30,000 wells that are producing. The San Juan Basin is only 4 miles away from the Rio Grande Rift, down in the area of the Jemez caldera, where the Rio Grande Rift intersects the Jemez lineament. And that's real important because most of the oil and gas exploration literally stopped in the San Juan Basin as it moved east because it ran into the Nacimiento uplift. And so the explorationists were looking east, and they're looking at a 11,000 or almost 11,000 foot mountain, granitic mountain there, and you can see why they didn't go any further. If you just move 4 miles across the southeast part of the San Juan Basin, you're into the Rio Grande Rift, and the same stratigraphy is still there, but it's buried under sand and gravel, and so it's hard to see. Okay. This is a indication of why we're interested in getting into the Rio Grande Rift right now. This is, if you look down to the extreme right side of this picture, you can see where that first discovery was located. And we originally came in at 40 barrels a day, and this was in the Cretaceous. This is just showing oil burning on the pits and gas flaring. But at the time, I got called back almost at the same time this happened. Oil went to $8 a barrel. I lived in Farmington and couldn't afford to come over here and play with this thing, so I just let it sit there because I owned the land and the minerals, so I didn't worry about that. This will give you an idea of why I continue to go after this. But after that well was drilled, nothing further was drilled in the Rio Grande Rift for years and years. Now, after I got released from active duty and retired, I came back and I got to looking at the rift in detail, and you can see the black oil ferrule, that discovery well off to the right there. This is a gravity map, synthetic overlapping transition zone. But it can be seen very nicely between the Albuquerque Basin and the Espanola Basin. Can you see my cursor? Hello.
Yes, we can.
Yes.
Okay, good. I just want to make sure you can see that when I put it on. Okay, that is a overlapping synthetic transition zone. That's real important because it's a high between two basins that have source rock and maturity in them. And of course, that's a good place to be looking for oil and gas. And this started off as an oil and gas prospect. Okay, I took that gravity map and I decided to make a little contour map. And so I cut out the thing and built up a little contour map so you could see it in 3Ds. And what you're looking at here is the transition zone. We call it the Zia structure coming through here. And these 3 wells were the only 3 wells that had been drilled in the Rio Grande Rift. And here again, just 4 miles away in San Juan Basin, you've got over 30,000 wells with the same stratigraphy. So after we put this structure map together, I said, okay, well, that looks good. Let's go buy seismic. So we did that. Bought 3 shell lines. This is the map of the structure on the basement or near basement. And you can see there's a structural high runs right through this. I have overlaid on that structure map. That's a time structure probably on the top of the Precambrian base, Pennsylvania. On top of that, you can see the seismic lines, and 3 of them are shell, 3 of them are Vastar lines, and that's all that was available. Later on, we in 2014, Department of Energy came up here and drilled a geothermal well for the Jemez Indians, and they have additional 3 miles that were available. So that is the network, and those are the lines that we'll be referring to. Now, go back. The first line I'm going to show you is this line right here. This is running south to north. And let's take a look at it. This is after I got the seismic lines, I went in and had them reprocessed. Now, you have to realize that reprocessing had come a long, long way since the 1970s. When we shot these lines with shell, it was just vaguely apparent that there was some kind of structure down there, and we could see some reflections, but we didn't know what they were. So we drilled that first shell Pacific #1, at the north end of the Albuquerque Basin, and lo and behold, the whole structure was there all the way through down to the Precambrian. So we knew the Cretaceous at the north end of the Albuquerque Basin was potentially there. But at that time, we were looking for deep basin gas. So instead of following up on that well, we started, I say Shell, made a big program going after deep basin gas. Here you can see this is a beautiful illustration, pardon me, of the whole section, and you can see it. You could not see this clarity before. You can see it now. That the beautiful thing about it is you can follow that, that Tadilto Entrado, which shines so nicely all over the Albuquerque Basin now, where it's present. So it made it very easy for me to do seismic up on the Zia because of the beautiful way that this is laid out. And you can see that there was a laramide uplift during the laramide, and you can see the Paleocene-Eocene beveling out and the Pliopleistocene on top of it. And you can see that there was structure pre-uplift, pre-laramide in here. And because the Paleocene-Eocene onlaps and covers that earlier structure, which is the kind of thing you like to see because there's already structural traps waiting for your oil and gas to come at you. Now, after we decided to do that, then we said, okay, that looks good, but do we have a petroleum system there? Is there something to go after? So my son and I, we went out on the lease that we had decided to take. on the Zia Reservation, and we have taken a lease. There's 33,840 acres at the present time, and we picked little samples every 600 feet, and these are the maps. The one on the left is the raw data. The one on the right is the smooth data, and you can see from the smooth data that you can see big highs in some areas, big numbers of C4s. That told us that C4, of course, is live hydrocarbon, and it told us that live hydrocarbon was coming to the surface. Now, when I got this, when we did this, I thought it was kind of a black box thing, but the majors had been doing this as regional geology in areas that they were looking, so I went ahead and took these. When we got them back, I could have sworn that that these folks already had my seismic, because when we laid it on the seismic, this is an example. This particular line is this line right here, going across the structure. And you can see that where we have the highs on the C4s, they are on top of gas chimneys, on top of areas where we have gas sags, and where we have bright spots, where we have beautiful you can see that happens. Microbial high here, you can see beautiful unconformity trap here, and microbial anomaly on top of this one. So that convinced me that yes, we have a petroleum system, and it's worth pursuing, going after this thing. This next line, is this is again showing the gas chimneys. You can see also in the Cretaceous, when you look at it, it's all broken up here. So it looks like it's fractured gas, perhaps. And this is a east-west section, also on the seismic. This is this line right here. And you can see the bright spots. You can see the gas sag. You saw that line, the same gas sag on the same line. So, I'm sorry, I keep catching this thing. Okay, and when you get a couple of lines that have the same data and the same thing happening where it doesn't happen anywhere else, you strongly suspect gas. And of course, you can see the nice gas chimneys coming off of this one too. And so we were getting kind of excited. So what we decided to do is let's take a look at all the rest of the data. We did have a problem though. When we looked at the gravity in detail, this happens to pay no attention on this map to these little triangles. The thing I want you to look at is these dots in here. Those are USGS gravity survey points. When we looked at that, lo and behold, it showed a great big old sag. Pardon me. It showed a sag right in the middle of our structural high. Now, this bothered us because on our seismic, where the sag was is where our high on the seismic was. And that didn't make much sense to me because I hadn't experienced a situation where you have a negative gravity on top of a seismic high in the basement on a granitic high. The only thing I dealt with in the past was Ventura Avenue out in California, a billion barrel field that had a big negative gravity there. My son says, Dad, could that be oil and gas? And no, that's just too much. That'd be too much to hope for. So what we did is we had a geophysicist come out of Oklahoma City, Mr. Patel, and he gave us a 40 triangular, where these little triangular dots are here. He gave us a 40 points, and we went in there, as you can see, and we did that survey. And then 2 weeks later, he came back and said, Mr. Black, he says, the USGS is right, and your seismic is obviously right. You have a great big gravity anomaly sitting on top of your structural high. Now, it's interesting because there is absolutely no low gravity in the sedimentary section. There's no salt. north of us in the wells. The well was drilled on the Jemez Pueblo, just a mile north of this area. There's no salt to the east of us up on the Colorado Plateau, where we have a number of wells. There's no salt south of us in the old shale wells. There's no salt in the east of us over clear across the Rio Grande Rift. So we have a big low gravity anomaly sitting on top of our structural high. Well, that says to me that we have to have something in there that is very low gravity, and that suggests we have a lot of oil and gas. So that's why we have concentrated now on eventually trying to get that high drilled. And we'll talk a little bit more about that in a minute. This is the line. This line comes up from the north going to the south. That's this line right here. And that is the structure that has a low gravity anomaly coming across the top of it. When my son came in and showed me the next day that there were oil fields all around the world with low gravity anomalies, it was because they were full of oil and gas, and many of them were billion-barrel oil fields. So if you look at the next slide, this is where we have plotted the gravity. On our gravity lines, we have all of these. This happens to be an example where the gravity is going across the top of the structural high that you can see on the seismic. The gravity is right, the structure on the seismic is right, and we have a big low gravity sitting right on top of the structural high. So we think that's full of oil and gas. This going back again, now let's talk about what we have done since then. We ended up putting 3 different wells, going ahead and getting 3 different wells approved through the BLM and the BIA. And we have those wells approved. We decided to drill the first one. And if you will look at this line, and over on the extreme right-hand side, that's the entrada to Dilto. The next slide will show you the same thing on a little different presentation. There's the entrada to Dilto coming up and going out. This is the same line, and this is where we drilled our first well. This is the Cerrito Negro number 1, and a mile north of it, as you can see, was the Department of Energy J1 that drilled on the Jemez Pueblo, and you can see that it went down to the basement here. You can pull these things up, and it's a perfect match. Now, the thing that was really interesting to us, though, was when you look at this line, you see a absolutely flat spot down here in what appears to be in the Basin of Precambrian, with the sediments rolling over above it in the Paleozoic and Mesozoic. So that's why we drilled our first well here. We spud that well back in February, and we have found ourselves oil sand, and we have found helium and hydrogen in the Albo Formation. We'll get into that here in just a second. But we thought this was very interesting to be able to see that flat spot so clearly, and we're convinced that, in fact, that is a true flat spot. It's probably a gas or oil water contact. This is the same seismic line, and this is, I laid it over so you could look down it. That's just as flat as it can be, and you can see very lightly the timing lines. Note the fade out down below it. That may be, we thought that might be fractured basement, and I think, in fact, we've now proved that it is. This then, okay, let's go back now and just a second, I got a distraction. We can see let's talk about the oil and gas and our oil and gas migration paths. Obviously, this is the west side of the Rio Grande Rift. This is the first block coming off of the high over here on the left-hand side. That's the Colorado Plateau. That's been faulted down several thousand feet. And then you can see the structure. This is across, this is 7 miles across here, and it's 14 miles long in an east-west direction. And the big faults are clear over, even further over to the east. And these are some of these faults over on the east side are going clear down. To get this same section, you have to go 20 or 25,000 feet to see the same section on the bigger faults that are also dipping to the east into the Rio Grande Rift. So the oil and gas that is migrating or that is generating from the Cretaceous source rocks, the Mancus and the Chedilto Entrada, as it moves up these faults, it only has one place to go, and that is up. As it comes up, we believe the oil and gas is migrating into the section, coming up here, and then trying to move high, high, high until it can get the highest point it can get, and then it gets trapped because it has either faulting or it has reverse dip over here. So we see, and that's where microbial anomalies are, sitting on top of that one, sitting on top of this, with a great big bright spots, and looks like maybe a flat spot sitting on this one, and with the rest of the gas and oil. So that's our model for oil and gas moving up into this structure. Now, we logged that well. This is a ELI wireline log, and we went in and unfortunately, I decided to run 5.5-inch casing when we thought we were getting into the Arctic sands just above the Precambrian. We ran that 5.5-inch, and this is a log of the, pardon me. This is a log of the well of our first log, and we ran the log down to a casing point at 3588. That's where the shoe of our 5.5-inch casing is. And you can see on the log that we have, this is a shale in the Sandia Formation. And that shale is just as sticky and as tight as it can be. And then all of a sudden we start getting this high in here. Unfortunately, our uphole timing was wrong. We did not catch, apparently, this last 30 feet. And I didn't know that until we went in later and decided to go down and take a look at the drill the 4 3/4-inch narrow hole down here, and we logged it. When we drilled out with a 4 1/4 and went into the basement to the final TD at 3889, the first sample that we caught right out from underneath this shoe, bingo, we were into an oil sand. We had probably already cut 10, 20, maybe even as much as 30 feet of this thing that we did not catch because when I ran the casing, I had the wrong uphole times. We cased the thing, and so I was absolutely surprised. This is what it looks like in normal light. That's what it looks like in the UV light. When this came on, wow, bingo, and we could smell the hydrocarbon. And we said, oh my gosh, we're into an oil sand. We thought maybe we had just cut it right out from underneath the base, the casing shoe. But in fact, we may already have cut it up whole. This is an example. Let me go back just a second. You can see that's the coarse sample here on the that high bright one, and then lesser ones as you go to the left there. That's the cut fluorescence on those samples. If you look at the samples, the next 30 feet below it, we only had a little bit of fluorescence in it. And when you wash the fine stuff, you can see you're into lots of micas, biotite, feldspars. So we think we're into basement by this time. We're through the Arctic sand and into basement. Okay, let's now move on to and talk about some more of the structure, because that's I'm sure what you're interested in. This is that same one that we showed you before. At the number 1 over here, we have a profound unconformity that's present in this central graben. You can see the big central graben on this structural high. And this is pretty typical of rift systems where you have a pull apart and you end up with a great big graben at the top of it falling in as the rift spreads apart on east-west spreads apart. And this is what's happening here. That's nice in one sense because you would think, gosh, if it's pulling apart, you're going to leak out all your oil and gas. But that acts as a keystone block. And as it comes down, it puts pressure on the faults that are dipping back to the west. And therefore, you get some good sealing traps in those areas, and you can get good sealing up in the high structures like number 2. You can see the bright spot in the first structurally high horse block here, up dip from the graben deep. And it's overlain by that nice microbial anomaly. There's on the western fold, pardon me, we didn't have as good a microbial thing. Okay, everybody still see that? Yeah, can you see that?
Yes. Yes.
Okay. All righty, let's go now and talk. We've talked about oil and gas, and you can see that we have found a oil sand. We're not sure exactly what we've got, but we've got 10, 20, maybe 30, or maybe even more arcosic sand that we have not yet tried to complete, but will shortly. This is a Google Earth picture now, and you can see where the Hamus liniment that we talked about earlier, you see it coming in from the west, and that's where that line of stuff comes up from Arizona and it heads directly toward the Hamus caldera that you can see up in the top of the picture here. And the highest air-corrected helium-3 to helium-4 ratios reported in the whole western United States occurs right here. You can see the ratios, 6.16 in the caldera, and clear down, even very high, clear down to the south and west as the Hamus River drains down here. And you can see where our lease is sitting on the down in the southern part of the thing. I'm almost afraid to point these things out because it keeps jumping on me. You can see where our lease is down here. And this is the highest ratio of HE3 and HE4 reported. This was reported by Carl Karlstrom and Laura Kazi in 2014 article. It was a beautiful example of apparently the faults in the rift are going deep enough to go through the crust or almost through the crust and possibly even into the mantle. And that's why we think the H3 is coming up at this area. And we think we just fortuitously leased a place where we're sitting on top of these faults that are coming up underneath us, going and as you can envision, coming up into and coming out. Hope this works. Can you hear that?
When the little square is showing, it's going.
This is our flow out of the Diablo. We went up and perforated the Diablo before we went on down, and you can see the gas coming out of here. And most of this is nitrogen. There's up to 1% helium and up to 11% hydrogen. And this is captured in all those sandstones.
We're getting an awful lot of gas coming off now.
Okay, let me show you what the get her back. My thing over here is covering. You can see on the what we did is we went in and I hope everybody can see that. Put a mass spectrometer on. We did not have a mass spectrometer on originally. My son, fortunately, had taking gas samples as we originally drilled through the Abo, and he had seen gas bubbles breaking out on the mud pit and on the possum belly. So he took samples fortuitously, and we put them into gas analysis service, and they came back and said, hey, you have helium and hydrogen in it in the Avo samples that we took. So when we did go ahead and drill deeper, we went ahead and put a mass spec on it. And you can see that we had, in this example, we have hydrogen up to 115,000 parts per million. That's 11% hydrogen, and that's gold hydrogen, absolutely pure. This one is showing our helium. We're getting up to 1% of helium. And these are just examples out of our mass spec, some of the better samples. So we know that we have now, we're into oil and gas, which we had expected to find. And we're also into helium and hydrogen, which we had hoped to find, but weren't sure whether or not we would see it or not. In fact, we do have it in the Abo in this in our sands. Here again is the same pictures, a little more that you can see of that. Okay, let's talk about what's happening and what's trapping. This is about 2 miles up from our lease up in the on the Jemez Pueblo, and this is a roadside cut, and you can see the Abo sands here, which show up very nicely, and you can see that the Abo is get her back. Somehow I have just lost everything. Sorry. I don't know how I lost that. Let me get my help in here.
Did the screen freeze on your end?
No, I've lost that for some reason. Hold on.
Okay.
I'll get it back. I apologize.
Oh, no worry. It happens.
Okay, here we go. Okay, there we are again. I apologize. What you're looking at here is the Abo formation, and you can see this Abo sands are 20, 30 feet thick, and they're sandwiched between 30 to 50 feet of Abo shales. Because it's a fluvial formation, these sands come and go, so they can both strat trap and they can also structurally trap. So any helium that is migrating up the east dipping faults that are dipping under this stratigraphy, any helium that comes out and goes into these Abo sands can then be trapped between the beautiful mudstones that are on the top and bottom of it. So that's what we think is happening. That's just an example. This is a close-up of our Abo sands, and you can see they're everything from very poorly sorted, coarse to very fine sandstones. This is just one example of a close-up of it. Okay, this is a now we can talk about what's happening with the helium, why it's coming up where it is. Obviously, just like the oil and gas, as the helium, both 3 and 4, come up, the helium-4 is mostly boiling off of the radioactivity that's taking place down here in the crust itself underneath the structure. But the helium-3 is coming up from deep in the mantle, and it's using the same faults to come up. And when it gets up in here, the helium-3 and 4 are both migrating probably together, and they come out in any sand that they can find. and move out and move along structure and go into your highs. That's why we think we have both the helium 3 and hydrogen, gold hydrogen, coming and being found where we are finding them. Now, I don't want to take too much time explaining that, but I do want to show you this. This is a gravity map of the Rio Grande Rift, and it shows where our seismic is and where our lease is. That's generally the Zia area that's circled there. This, I'm going to blow this down and show you this, and we're going to overlay the Rio Grande Rift gravity on top of our analog. We think the best analog is the Gullfox field in the North Sea. This is a picture of the Gullfox field along with the Magnus and Britain, Ninian, and some of the others. This is a picture of the Viking Graben, and you can see where the Gullfox field is located here on the west edge, and it's sitting close to the transition between the two basins. Now I have overlain the Rio Grande Rift on the same, virtually the same scale, and you can see the similarities. When you look at it, it's almost canny because you can see that we have a transition zone between two basins in the Rio Grande Rift. You have the same type of thing. If you go back and take a look at the Viking Graben, you have the transition zone between the in the two basins in the Viking Graben, and when you overlay it, you can see what happens. Now, if you take it back and forth, when we did this, we said, "Oh my gosh, that looks pretty interesting." Now, the Gullfox field is now going to be at least a 2 billion barrel oil field. And we know that we're sitting on top of a high at Zia, and it looks like that thing is full of gas. So we have great hopes that we'll have not only gas and oil fields, but that we may have high hydrogen and helium in that situation. Let's go down now, and we'll show you. That is kind of impressive to me. Let's talk about the infrastructure. This is our lease right here. And we're fortunate to have a number, unlike most prospects that I put together in the past, I usually end up 50 or 60 miles away from a gas pipeline. So gas, a lot of times you say, oh my gosh, it's going to shoot the prospect down. Nobody's going to be interested. Well, it turns out that we have 8 lines running right down the highway that crosses right through the Pueblo and right through our lease. And you can read on the thing here, Enterprise operates 4 liquid vape lines. Kinder Morgan operates a CO2 line. Western Marathon has 16-inch crude line. Enterprise 4-inch, so on, so on, so on. And we're just a few miles away, about 6 miles away from this old pipelines, the major pipelines that run out of the 40 inches out of the San Juan Basin. So that's your infrastructure. This kind of gives you a picture of the total Pueblo acreage. Our lease is shown there in orange, and you can see where our seismic lines are in there. And this is again on Google Earth. And the highway, I think if you look real carefully, you can actually see it coming from the San Juan Basin right in here across the Nacimiento High, and then right across the lease down Highway 550. And we're only 15 miles away from the railroad down at Santa Fe Pacific Railroad. This is now let's talk about, we can show some of these logs. Here again, we go back to the Ely log, and you can see on the right-hand side here that high resistivity kicking up. We think we have missed a possible oil sand, top of the oil sand in here because we were off on our uphole times. And if you look over here on the Leith log, this is a Leith evaluation log. you can see down here, right in there, all of a sudden we get a FDCC and crossover right here. We think that may be the top of a gas sand. So we're going to be real interested in looking at all of these as we go back in and try to complete these zones. This is just some additional logs that we can share with you later on. But at this, again, there's that Leith evaluation log with the FDC CNL density crossover. We can go to questions, and I hope I haven't run out of time. I haven't been watching the time. How we doing?
You're doing great. We've got about 15 minutes left before 1.
Okay.
That was really enjoyable. I'm personally a little bit jealous you get to prospect and all that cool structure over there.
Well, we're shut in right now, and unfortunately, at a small 4-member family, we have run out of resources, so we're looking for partners now. So we're going to be looking for people to come in and help us get the oil sand completed and go back and find out where the hydrogen and helium are coming from out of the Abo.
Awesome.
So anybody that's watching, give me a call. I'll be glad to talk to you.
Yeah. I even saw just, you showed some of your seismic lines, and I saw some, even though it's just a 2D view, I saw, what could be structure traps and some additional flat spots. So it looks like a really fun area to work.
Yeah, it really is, and it's all over. The beauty is that seismic is so easily interpreted now. When we were with Shell, that was all very vague, and the reprocessing wasn't what it was now. And so I was just delighted when we got the reprocessing back in. It turned out so nice.
Awesome.
I think we can do a lot with it, and I think this will open up hopefully the Rio Grande Rift to more exploration.
Yeah, definitely. Okay. If you guys have a question, we can do this several ways. At the bottom of the screen, you'll see a little Q&A box. You can type your questions in there. You could also go ahead and use the chat if that's what you're familiar with. And I believe there might be a button at the bottom where you can raise your hand, and that'll kind of flag you. And if you do that, I will call on you and there's a button that says allow to talk. So I will allow you to talk. But for now, whoever has a question, feel free to raise your hand or type it into the chat. Just curious, did you use any magnetic data, like with your gravity data? Did that help?
We did look at the magnetics. I'm not a geophysicist, and I could not see anything but the gross magnetism that told me anything more than we were looking at with the gravity and the seismic. But I would be happy to have somebody look at the magnetics and tell me if they think that can help us.
Yeah. I love grav mag data. All right, Robert Colpitts, I'm going to allow you to talk. I think you're on a panel now, so I believe if you unmute yourself, you'll be able to chat.
Can you hear me?
Yes.
Yeah.
Okay,
Hi.
great.
Hi, Bob.
Well, it's good to see you again.
Well, good to hear from you.
This is very good because I prospected this area before Bruce got involved with another group, and yeah, we did use the air mag, and we were integrating air mag and whatever we were trying to purchase the seismic, and our geophysicist, he did get it reprocessed, but this was like, oh man, 20 years ago. So but nothing ever came of it. We weren't able to move forward with it. I'm glad you drilled the well up there. Yeah, we saw a lot of the same things you did, Bruce. And we certainly saw on the air mag the faulting that you were showing. I'm really glad that you got the seismic reprocessed, because we had in our idea bag, we were going to shoot 3D, across this south of 550. See what that looked like. So congratulations on finding something. That's really great. I'm really pleased that you drilled the well. I'm sure there's funding around. People like to get into wildcats. I might talk to my people to see what they
Good, Bob.
think
Yeah,
about it.
send me your email too, Bob, so I can attach with you. I appreciate your
Okay, yeah, I've got your contact info. I put it on my phone, so I'll send you an email.
great. Good.
So good job. One thing that struck me was it looks a lot like the Bronco field, where you have relaying grobens, and you have a cross, so you have a step over between the grobens, and the oil sitting up in those across those step overs. And they pulled a lot of oil out of the Bronco field on a high, just like you have described here. It looks just like that. It's a little smaller in area than what you're dealing. You're dealing with a much larger structure, and the grobens over there on north and northwest of the Central Basin platform, there on the Lee and Yoakum County lines, is a bit different. That's a Paleozoic rift that formed during the ancestral Rockies. Bureau of Economic Geology is trying to tear that apart and see what's going on. They're scratching their head because they got so many deformation events overprinted on each other, and you're getting up there towards the Matador Arch, and it vanishes into thin air. But that's something Molly should go investigate. I think that'd be perfect that'd be right up your alley, Molly.
It would be.
But good job. That was an excellent presentation. And I was going to mention to you also that one project we worked on down at that I was working on down near Belen. We drilled down on the flank. There's an intra rift horst block there at Belen, and that's been identified on 2D seismic as a proprietary shoot. And the company I was working for, we drilled a couple of wells. One of them produced gas, but it was loaded with argon, argon and nitrogen.
Interesting. Bob, I appreciate that.
Inerts are the thing. Yeah.
Cool. Good conversations. There was a question submitted anonymously. It says, is there a market now for using the helium or hydrogen?
Oh, absolutely. There's a big market, as I understand it. At one time, helium was going to the Japanese for over $1,000 per MCF, when we're getting $3 per MCF for natural gas. Right now, I think the latest I saw was about $300 per MCF for helium. And hydrogen, I am not nearly as familiar with the hydrogen market, but I know that everybody's trying to get into it, particularly gold hydrogen like we have, because you don't have to process it or anything. We can take it directly out of that well, separate it from the helium, and sell it directly as pure hydrogen. And that's a nice thing to have. And we're going to be looking into how we can get that processed.
Awesome. Cool. Paul Prigitel says, great presentation. And then we have a question from Greg Clark. Have any logs been submitted to the agencies for the Cerrito well?
To the who?
Have the logs been submitted to any agencies for the Cerrito well?
Cerrito Negro. No, they haven't yet. We're holding this tight right now. And you can imagine it'll be a while, I'm sure. When we do submit them, they should be available.
Awesome. Next question comes from Nick Brissett. Nick, I added you to the panel in case you want to unmute yourself, but with the structural complexity linked to faulting, was there any drilling issues either due to extreme dips? Did you guys have any issues and how did you resolve those?
No, we didn't have any problems at all. We went right down. We kicked that initial hole right down to where we cased it in a day or two. No problems. It drills just like San Juan Basin. Although we were actually in that well, we were starting out in the Triassic and went to the Precambrian. We had no problems at all. I'm sure you could if you got into cross faulting, but as long as you stay in one of those blocks that are running north-south, and obviously we're going to go back in and shoot 3D and find out where all of the cross faulting is, because we could have hit cross faulting we weren't aware of. That where we drilled on a seismic line, that north-south seismic line, and it looked like we had a full section from the Triassic on down, which we did. In our future already approved APDs for deeper wells and a shallower one. Those are also on the 2D lines where we're drilling on the lines, so we be sure that we don't hit something we don't expect. But I'm sure that you could run into some problems, but we're trying to stay on seismic lines to avoid it.
Yeah. Awesome. Okay. Next question is from Nicholas Guerrero. What is the source of the helium?
Good question. I would assume that it is coming right out of the mantle too, and obviously you have to have something that will keep the helium from semening up with other things as it comes up. And I'm sure that the helium is coming up as virgin helium, and so it's being caught, and we're catching it before it has a chance to really get combined with other atoms. I'm not a chemist, and we're in the middle of trying to figure all that stuff out. I wish I knew, and if somebody can tell me, I'd sure appreciate it.
Yeah. And then last question so far, is Bruce working by himself with his own resources? And then we kind of just answered this, but he was also curious where the helium and hydrogen came from.
Okay, yeah, we're working with our own resources right now, and we're skinny on that, so we're looking for a good partner or some kind of a situation where we can get somebody to come in and help us complete these wells and do further work on completing the helium and hydrogen. We think we're onto a real true potential giant here, because we've just scratched the surface, and this is the first well we've drilled, and we've seen everything that we wanted to see, and proven that the hydrocarbon is there, source rocks are there, maturity is obviously there, and we have our better prospects like Kawami, which is going to be a 9600 test. The next one we'd like to down to the south, about 6 miles to the south on our acreage, and it's sitting right on top of right in the middle of that big gravity anomaly, that big gravity low on that structural high. We think that thing's going to be loaded, and we're looking for a partner to come drill that well for us.
Awesome. Well, maybe I'll win the lottery.
Yeah.
Partner with you. Lots of fun structural geology to look at. Awesome. Well, we're right at 1 o'clock, so I'm going to go ahead and shut this down, but just want to say thank you again from PSGD. Really enjoyable talk. Thank you for allowing us to record. I will probably upload this to YouTube within the next few weeks. Just ping me if that's an issue or anything at all. But really enjoyable. Thank you again, Bruce. And
sure.
You're getting some claps and some awesome thank you notes on the chat as well.
Okay, well, thank you all, and you know my email. Give me a call if you want to talk about it. I'd be glad to answer any more questions. Thank you very much.
Awesome. Thank you, guys. See you, everybody.
Okay, bye-bye.
Bye.